AI, it's revolutionizing everything, isn't it? I mean, from those self-driving cars to predicting the weather, it's mind-blowing. But
Really,
we rarely stop to think about what's going on behind the scenes.
right. All those AI systems powered by some really complex hardware. We're talking GPUs, CPUs, the whole works.
And someone's got to make sure those systems are running smoothly, right?
Exactly. And that's no easy task, let me tell you. It's a whole other world of intricate processes and potential pitfalls. We're diving deep into that world today, the world of debugging AI systems.
And to help us navigate this maze, we've got insights from two experts at Microsoft Azure.
We've got Anna Mary Matthews, she's a director there and leading the charge in this field.
And Tommy Yan, a GPU project lead who's in the thick of it every day, tackling those debugging challenges head on.
And they've got some stories, let me tell you.
I bet they do. Well, Anna Mary kind of sets the stage, right? I mean, she talks about how these AI GPU systems are becoming more complex than ever before.
Oh, absolutely. You've got components from all these different manufacturers, each with their own quirks, and they've got to work together seamlessly.
Like a well-oiled machine, or at least that's the goal.
Right.
And any little hiccup can bring the whole thing crashing down, am I right?
Oh, absolutely. It's like, one instrument out of tune in an entire orchestra, it just throws the whole thing off.
Exactly.
Yeah.
And that's why Anna Mary argues that we need a major shift in how we approach, this whole debuggability thing. It can't just be an afterthought, something we tack on at the end. It has to be baked into the design right from the start.
She's saying don't wait for the fire to start before you figure out where the fire extinguisher is.
Yes. And it makes perfect sense. I mean, you wouldn't design a car without thinking about how you're going to get to the engine to fix it if it breaks down, right?
Exactly.
So why on earth would we design these AI systems without considering how we'll troubleshoot them when something inevitably goes wrong?
And that's where those debuggability requirements that she talks about come in. It's like providing a detailed map and a well-stocked toolkit to those tasked with keeping these AI systems up and running. Think about accessibility. Think about tools. Think about making it easier to pinpoint issues quickly and effectively.
It's all about giving those debuggers the best possible chance of success. Because when these systems go down, you need answers fast.
Exactly, and that's where Tommy Yan and his team come in, right? He dives into the nitty-gritty of their debugging process at Microsoft Azure, and it is fascinating stuff.
So they're the ones on the front lines, those digital detectives, right?
Precisely. He breaks it down into 3 core steps. First up, identifying those reproducible and non-reproducible scenarios.
Okay, so figuring out if it's a consistent glitch or just a phantom in the machine.
Exactly. And to do this, he highlights 2 main approaches, accelerating issue reproduction and swapping out components.
So speed is key here, right? We're talking about systems that operate at lightning speed.
Absolutely. It's like hitting fast forward on a movie to get to the good part, the part where things go haywire, so you can gather those crucial error logs faster.
Time is of the essence. So what about swapping out components? Is that like switching out ingredients in a recipe to see which one is causing the cake to fall flat?
Got it. By systematically replacing hardware and firmware, Tommy's team can often pinpoint if a specific component is the culprit. That brings us to step 2.
Okay.
Pre-aligning and collecting those all-important logs on fail.
Right. So it's not just about hitting record when things go wrong. You've got to be smarter than that.
Exactly. It's about having a plan of attack. A
Yep.
detailed game plan for capturing the right data at the right time.
I see.
Tommy compares it to having, like, a crime scene investigation kit, but it's ready to go before the crime even happens.
That's some next level preparedness.
Absolutely, because sometimes, the system doesn't completely crash. It might seem to recover, but those logs from that near-death experience, those can be super valuable later.
Oh, I see what you're saying. It's like those black box recorders on airplanes.
Yeah.
They can reveal what went wrong even if the plane makes a safe landing.
Precisely. And sometimes you're not so lucky. Sometimes the system hangs completely. But Tommy's team, they've got strategies for capturing logs even in those tricky scenarios.
Oh.
And now for the third and final step,
Okay.
correlating, analyzing, adjusting, and reproducing.
So this is where it gets really interesting.
This is where it all comes together. It's all about connecting the dots between those log entries, forming hypotheses, and then rigorously testing them by trying to reproduce the issue.
It's like a puzzle then.
It is a puzzle. It's an iterative dance of observation, analysis, and experimentation.
So you don't always get a straight shot to the solution.
Rarely. It's more like navigating a maze. Plenty of twists, turns, and dead ends, but each attempt, each iteration, it brings them closer to understanding that root cause.
I can see how that could be frustrating, but also rewarding when you finally crack the code.
Oh, absolutely.
And this is where those debugability requirements that Anna Mary talked about, this is where they come into play, right?
Big time. It's one thing to have a methodology, but without the right tools, without access, it's like trying to solve a puzzle in the dark.
Right. You need the right tools for the job. So let's talk about those requirements. What are some of the key things that Tommy's team really emphasizes?
Well, first and foremost, they need access to a hardware debugger, and it's got to be fast.
Makes sense. Every second counts when you're dealing with systems this complex.
Exactly. We're talking about minimizing that time it takes to collect those crucial logs. Every second counts. And it's not just about speed, it's about accessibility. Tommy advocates for open access to those binary logs, not just for the component manufacturers, but for customers and partners too.
So democratizing the debugging process, so to speak.
Precisely. Because oftentimes the most insightful clues, they come from those who are closest to the problem, even if they weren't the ones who built the hardware.
Okay, that makes a lot of sense. Now, I have to admit, this next one, it threw me for a loop a little bit. PCIe analyzer connectivity.
Ah, yes.
Can you break that down for me?
Sure. Think of the PCIe as like the central nervous system of these AI systems.
Right.
It's how all the components talk to each other. Now imagine having a device that lets you monitor those signals traveling through that nervous system. It's like a high-tech stethoscope for your computer. That's what a PCIe analyzer does.
You can see what's going on under the hood, so to speak.
Exactly. You can see if signals are getting crossed, if there's any interference, any hiccups in the flow of information.
Wow, that's incredible.
And last but not least, we have streamlined security exceptions for remote debugging.
Okay.
This one is all about efficiency. It's about making it easier for experts to parachute in remotely and help troubleshoot without all the usual roadblocks.
I see.
Yeah, things like restrictive security protocols or needing specialized firmware for each session. It's all about streamlining the process so that the best minds can collaborate quickly and efficiently.
It's about getting the right people on the case as quickly as possible.
Exactly.
Okay, so we've got the methodology, we've got the requirements. Now, for the moment of truth, the case studies.
Right. Tommy walks us through 3 real-world examples of his team tackling some seriously challenging debug scenarios. And let me tell you, each one reads like a detective novel.
Oh, I love a good detective story.
And just like any good detective story, they all start with a baffling mystery.
Okay, so what's the first case?
Case study number 1. We've got GPUs that seem to vanish into thin air during boot up.
Wait, what? How does a GPU just disappear?
That's what Tommy's team was trying to figure out. And the initial signals, they seemed normal. They were seeing the signals being sent and received correctly.
So what was the problem?
That's the million-dollar question. The key to cracking this case lay in digging deeper into the timing of those signals.
Timing.
Yes. It turned out that while the baseboard management controller, or BMC, was receiving those signals correctly, it was sending them out too early or in the wrong order, causing the universal backplane management, or UBB, to miss them entirely.
So it's not just about the signals themselves, it's about the precise timing and sequence of those signals.
It's like a perfectly choreographed dance routine. One misstep and the whole thing falls apart.
And this is where that PCIe analyzer comes in handy.
You got it. Without it, they would have been trying to debug a silent movie.
Right, trying to figure out what's wrong just by watching the dancer's feet moves, but not being able to hear the music.
Precisely.
Okay, on to case study number 2.
All right. This time, we've got PCIe switch and retimer issues rearing their ugly heads during boot time, causing the system to slow to a crawl.
I hate it when that happens.
And true to the methodology, Tommy's team focused on quickly reproducing the issue. They actually had to get pretty creative with log collection, using a special debug firmware to prevent those crucial early error logs from being overwritten. And they even used a dongle.
A dongle. To collect logs.
To access the logs from the PCIe switch directly, yes.
Talk about thinking outside the box.
They had to become tech MacGyvers. And their persistence paid off. By carefully analyzing those collected logs, they uncovered handshake timing issues between the UBB retimer and the PCIe switch during the PCIe training process.
Handshake timing issues.
Yeah.
Sounds more like a diplomatic summit gone wrong than a computer problem.
Well, in a way it is. It's all about ensuring those different components are communicating effectively and that their timing is perfectly synchronized. In this case, there was a slight misalignment, and that was causing a bottleneck in the system.
And slowing everything down.
Exactly. Now for our final case, case study number 3. We're dealing with a real showstopper here. PCIe switch issues causing the system to crash mid-operation.
Yikes. That sounds serious.
It was, and again, reproducing the issue quickly was paramount. This time, they used specific PCIe workflows to trigger those crashes, and they used a special tool to access that switch directly. They were also able to use something called OOB access, out-of-band access, to gather logs from the retimer even when the main system was unresponsive.
So it's like having a back door into the system even when the front door is locked.
Exactly. And what they discovered was that the root cause was a hang in the PCIe switch firmware itself. Imagine a traffic light suddenly freezing in the middle of rush hour, complete chaos.
Definitely not what you want in a system designed for high-performance computing.
Not at all. But by meticulously following their methodology and using the right tools, they were able to identify that faulty firmware and get that system back up and running.
Wow. These case studies are amazing. They really highlight just how much detective work is involved in debugging these AI systems. But it also makes you wonder, how can we make this process more efficient, less reliant on such specialized knowledge?
That's a great question, and it's one that both Anna Mary and Tommy are really passionate about addressing because as AI systems continue to evolve in complexity, so too will the challenges of debugging them.
It's like we're in a race against complexity, trying to stay one step ahead of those debugging challenges.
Exactly, and it's a race we can't afford to lose. Think about it. AI is everywhere, right?
Yeah.
It's being integrated into healthcare, finance, transportation, you name it.
It's true.
The reliability and safety of these systems, those are paramount.
Absolutely. We're not just talking about our favorite app crashing anymore. These systems have real-world consequences.
Exactly. So how do we bridge this debuggability gap? Well, Anna Mary's idea about, shifting how we approach design, that's a crucial first step.
Right, so baking debuggability into those initial blueprints.
Yeah. We've got to move away from treating it as an afterthought. It's got to be in the DNA of these systems from day one.
It's like those diagnostic ports they build right into spaceships. You don't want to be trying to jury-rig something when you're already in orbit. Right.
Exactly. And it's not just about the hardware itself. We need standardized debugging interfaces, tools, protocols, all of that.
So instead of everyone speaking a different debugging language, we need a universal translator.
Precisely. Imagine a future where engineers can just seamlessly move from debugging one AI system to the next. No problem. No need to learn a whole new set of tools and techniques.
That would be incredible.
It would be a game changer. And we can't forget about the human element too, right?
Right. We're still going to need those skilled debuggers to make sense of it all.
Absolutely. We need to invest in training and education, creating a whole new generation of debugging wizards.
Debugging wizards, I like that.
Engineers who are fluent in the language of AI, but who are also masters at, unraveling those complexities.
So it's not just about building better AI systems. It's about building better debuggers, too.
Exactly. And, perhaps most importantly, I think we need to foster a culture of proactive debugging.
Okay. So what does that look like? Proactive debugging.
It shouldn't be a last resort, right? Not a reactive measure that we just pull out when things go haywire. It needs to be an integral part of that development process from the very beginning, day one.
So we're shifting from firefighting to fire prevention in the world of AI.
Exactly. By embracing proactive debugging, by thinking ahead, we can identify and address those potential issues early on.
Which ultimately makes these systems more reliable and safer for everyone in the long run.
Precisely.
This deep dive has been incredible. We started by marveling at the power of AI, but now we're really starting to appreciate all those hidden complexities beneath the surface.
It's like we got to peek behind the curtain of a magic show and realize that even the most dazzling illusions, they're the product of, meticulous planning, flawless execution, and of course, a bit of troubleshooting along the way.
Always a bit of troubleshooting. And as AI continues to evolve at this incredible pace, it's comforting to know there are brilliant minds like Anna Mary and Tommy out there, making sure we can not only build these systems, but that we can understand them, manage them responsibly.
Absolutely. It's a journey, for sure, this whole AI thing, a journey of continuous learning, continuous improvement. But one thing's for certain, the future of AI, it depends on our ability to debug it effectively.
And on that note, we'll leave you with this final thought. As AI becomes more and more integrated into our world, what role will you play in shaping its development? How will you ensure its responsible use? Until next time, on The Deep Dive.